All right, guys. Hey, welcome back to part two. Okay, where we actually solve a system using a matrix. Okay, so that's the goal. Today we're gonna do three examples. Okay, and we're also gonna discuss like differences of how we can solve this because there are places where we can stop and use back substitution to find the rest of it. So anyway, let's go ahead and get started. So here's my first system. Okay, and my first step is to put this in what's called an augmented matrix. We talked about that in the first lesson. We're literally just plucking out the coefficients here and we're putting it into this matrix because we talked about how it doesn't really matter if I include x's and y's in this guy, okay? Based on its position, that's where the x's and y's are. So this is a 1, this is a -1, this is a 4, and then this guy's a 3, right? I just took them out. Now the augmented part is me doing this. Boom. We're going to add on to this matrix, and it's going to be the coefficients here, 11 and -5. There we go. Okay? So that's what it looks like. Now, if you remember, the first column is our x's, the second column is the y's, right? And you can see that by looking at this guy over here. First column x's, second column y's. Okay? So here's what I want to do. Okay, the first part, I'm going to use what's called Gaussian elimination. Okay, this is what this looks like. So what I'm going to do, my goal, okay, and I'll write it over here. I might have to erase it, sadly. My goal is to get a 1 in the 2-2 position, okay, and a 0 in the 2-1 position. Okay, so it's going to look like this. This is what I want. Okay, the little asterisk here is just other numbers, but that's what I want. Okay, the reason why I want it to look like this, remember this first column is x's, right? The second column's y's. See how this is 0 x's? 1 y equals a number. This is a y equals something. So that's perfect, right? That solves one of my variables, okay? So just keep that in mind. That's the goal, okay? All right, so how am I going to do that? Well, we're going to use some elementary row operations for this guy. Now, I personally like to write little notes as to how I get to the next step. That's what I'm going to do. So R is row, okay? And then whatever I put in front of it, I'm multiplying and so forth. So how am I going to do that? Well, I want to get a 0 in this position right here, okay? So for me to do that, I can multiply what? This row by a -4, right? And add it to this guy. Sound good? And then this will be a 0, okay? So let's do that. So -4 times row 1 plus row 2, and then I'm going to get a new row 2. Okay, row 2 is going to change when I do that. Now, I'm going to be very clear. When I do multiply the very top and add it to this guy, I don't change the first row. I don't change it all. It is what it is. Okay, so let's do that. So now, I'm going to rewrite the first row right now. I'm not going to, oops, sorry. There we go. Okay, I'm not changing that first row. I just want to change the second row. Okay, so -4 times this is -4, plus 4 gives me 0. There's a 0 there. Okay? All right. Next up, -4 times this guy is 4, plus 3 gives me 7. -4 times 11 is -44, plus -5 is -49. So this second equation right here is 0 x's plus 7y equals -49. I'm going to write that down real quick. This is what this is. We're going to translate. That's what this second row looks like. So the x's are gone. Look, it's just 7y equals -49. How do you solve that? Divide, right? Now, we don't actually divide with a matrix. We multiply by a fraction to do that division. Okay? So let's do that. So what I'm going to do is I'm going to multiply row 2 by 1/7. and then I get a new row 2. Okay, let me just tilt the camera down a little bit because we're going to run out of space if not. All right, so once again, row 1 does not change. I am not looking at that whatsoever. Okay, row 2, I'm going to divide everything by, or 7, but multiplying by 1/7. So this is a 0, this guy's a 1, and then this guy over here would be what, -7? Okay, now, in this instance, we would stop. This is, Gaussian illumination would say, hey, stop here, we're done. Okay, and why am I saying that? Well, let me show you. Okay, I'm going to have to adjust the camera here a little bit, so I do apologize. Let me just... Okay, so looking at this guy down here, this bottom value is saying y, because remember, this column is the y's. So if I look at just this bottom equation, 0x's plus 1y equals -7. I'm going to write that down here just so you can see it. 0x's plus 1y equals -7. Okay, so y is equal to -7. Oh no, you can't see that. No. There we go. Okay, so y is -7. That's what this guy's telling me down here. Awesome. That's perfect. So now, let's look at the top equation. Let's translate it. So the top equation says we have 1x, we have -1y's equals 11. Okay, see how I took this guy and just translated it? Okay. Now, what I can do is I can use substitution, right? I'm going to substitute what y is into this guy and solve for x. So x minus a -7 equals 11. So this is just a +7. And then when I subtract, I get 4. Okay? So my answer is going to be y equals -7, x equals 4. And what I could do is I could take these guys and plug them back into the original and see if it works. And it will. Okay? So, I mean, this is a point, so I shouldn't do this. We're solving a system, so technically your answer is going to be a point there. And we're done. Now, we could go further, and that's what I want to show you here. Okay, let's say I didn't stop here. How can I get to these answers by using a matrix still? Okay, and this is where you're going to have that option. Okay, you can either do this, get your answer, or you can do what I'm going to show you next. Okay, so I'm gonna erase this, guys. Okay, boom, it's gone. All right, I'm going to rewrite this matrix over here. We're moving stuff around here. So let's say we didn't stop. Okay, let's say we kept going. Wow, you can't see that. There we go. Okay, so what do I do next? Well, I know what y is, right? So up here, I just want x to have a number. I just want x to have a 1. I want this guy to be a 0. So that way the top row reads 1x plus 0y equals whatever the number is. Okay, so let's do that. I think if I add this row to this guy, these ones will cancel. I get a 0 up here if I do that. So let's actually do that. Row 2 plus row 1 gives me a new row 1. Okay, I'm not changing row 2. I'm only using it to help me figure out what x is in row 1. Okay, so my first step, so I remember, I write down the second row, okay, because I'm not changing that. That's why I wrote this little arrow to row 1. I'm only changing this one. Okay, now let's actually do the operation. 0 plus 1 is 1. 1 plus -1 is 0. And then -7 plus 11 gives me 4. Okay, now this is the goal. 1s are in the diagonal, 0s are everywhere else. So what does this look like? Well, I'm going to translate it to you. So this top row says 1x plus 0y's equals 4. This guy over here says 0y's plus, 0x's plus 1y equals -7. So realistically, this is saying that x is 4, y is -7. And we're done. Once again, it is your decision. You could stop here and then just use substitution to find the other guy. Or you can continue to solve and get ones on the diagonal and still get to the same answer. Okay. Alrighty. Let's try another example out. Okay, let's try example 2. Kind of did this on the fly, but I think, yeah, I might just stick with 2 examples in this video. I think it's going to be long enough. Okay, so we'll do one more example. Okay, and then we'll go from there. Okay, so here we go. Example 2. Example 2. So 3x minus 2y equals 4. X minus y equals negative 2. Okay, that's what we're going to try and solve for this time. Alrighty, so let's go ahead and write this in an augmented matrix. So we're literally just taking the coefficients out. So this is a 3, 1, negative 2, negative 1. This would be 4, and this would be negative 2. Okay? Remember, these are the coefficients in front of the variables. The constants are right after this vertical line. Alright, so now what do we do? Well, once again, we want to have, what, a 1 here and a 1 up there, and zeros everywhere else, okay? And once again, I'll solve this 2 different methods for you. So here's the deal. I know I want a 1 up here in this corner. I always want that. Hey, row 2 has a 1. Let's switch them. Let's switch the rows. So row 1, we're going to switch out with row 2. Why not? Okay, I think that'd be perfect. So here we go. Therefore, I get that 1. I'm going to swap the rows out. But think of it this way. If I took these equations and flipped them, it doesn't change anything, right? It's still the same 2 equations. So just kind of keep that in mind. Don't think it's like some illegal rule. No, I'm not changing nothing. It's still the same. Okay? All right. I got my 1 up there. Perfect. And honestly, when I'm going through this, that's what I'll be looking for. Making sure there's a 1 here and a 0 here. That's what keeps me straight when I'm solving these. Okay, so I want to make this guy a 0 next. So if I multiply this by negative 3 and add it to this guy, it becomes a 0, right? So negative 3 times row 1 plus row 2 gives me a new row 2. And I'm only changing row 2. I know I'm multiplying this by a negative 3, but it's temperamental, just to get rid of this guy. It goes back to its original numbers afterwards. Okay, so let's go ahead and do that. Okay, let's see what we get. So negative 3 times 1 is negative 3, plus this guy is 0. And I'll apologize right now. I should have put row 1's values there, because we're not changing them. Negative 3 times this is 3, plus a negative 2 gives me a 1. Well, this is going to work out nicely. And then negative 3 times negative 2 is 6, plus 4 gives me a 10. Now, Gaussian elimination, you would stop here. This last row is literally 0x's plus 1y equals 10. So y is just 10. That's what this last row says. Perfect. So what I can do is substitute, right? So let me just push this over here. This top row is 1x minus 1y equals negative 2. Well, I know that y is 10, right? I solved for that already. So what I'm going to do is plug this into here. I'm going to substitute. So 1x minus, 10 equals equals -2. Add 10 to the other side. We get, what, 8 for that guy? Okay, and we're done. We just solved this system. Not too bad. Pretty cool. Okay. So what I want to do now to finish this, because right now we're at 15 minutes. This is getting kind of long. Let's say we didn't do that. I'm going to erase this. Let's say we wanted to continue. So that means I need a 0 up here so that all I have is x's. So I think there's only one option left, huh? I'm going to add row 2 to row 1 to give me my new row 1. If I add 1 to this guy, I get a 0, and that's what I want. So let's do that. So up here, I didn't change this guy, so it's going to stay the same. Okay, I didn't change it. So now when I add these, 0 plus 1 is just 1. 1 plus -1 is a 0. And then 10 plus a -2 is an 8. So now if I translate each one, this one says 0x's plus 1y equals 10. This row says 1x plus 0y's equals 8. So essentially, get rid of the 0 part, right? This says y is 8. X is 8. And then this says here that y is 10, which is what we got originally. Okay? So my answer becomes 8, 10. That's my coordinate point. Okay? All right. So this example, we exchange rows. So that way we can get a 1 in this position, okay? And just kind of looking at this, because a lot of people get confused, and for some reason the marker I used just vanished. That happens, I guess. Oh, no, wait. Found it. Aha. Oh, nope, dropped it. Hold on. Okay, found it. So here's the goal. If I was going to summarize this, okay, you always want a 1 in this position. You're looking for a 0, okay, in this position, and you want a 1 in this position. So you're going in an L format, okay? That's what you want to do when you're approaching these problems. It makes it a lot easier that way. Now, what happens when we do a 3x3 matrix? Well, there's a lot, there's a lot more involved, okay? It's still the same process. So for instance, let's say I had a matrix that looked like this. What if I had a 3x3? What would I do? Same thing, really. It does depend, I will say. I'm not going to lie and say, you're going to do the same thing for everything. It just depends on the problem. And the more you solve with these, the easier it becomes. Like you start seeing little things that you can do. But in this case, you would do the same thing. A 1 in this position, 0, 0, 0, 1. That's your goal, okay? Just like over here. Okay, you're trying to fill out this little L shape. And once you do that, you can use substitution to find the rest, or you can use elimination, continue, and get the other values in there. Because that's the goal. You want it to look like this. So that we have one z value, one y value, one x value. Okay? That's it, guys. I will upload my notes so you can take a look at it. I might do a part 3 when I actually solve a 3x3, just so you guys can see that. But we'll see. All right? Until next time, guys. Have a good day.